Hey everyone, it's Miss Cuban here. In this video we're going to talk about using probability to make predictions for future events. You'll find that this is very tied and related to proportions and ratios of making future predictions, what should happen. But I do need to make a disclaimer. I am, by copyright law, a lot of the resources and problems are not mine personally created. I am using Maneuvering the Middle resources, and so I want to give credit where credit's due, out of respect. So always got to make that disclaimer. And with that being said, let's go ahead and begin. So when you're making predictions for probability, it can be used for future occurrences by setting up and solving a proportion. And proportion is, in our class we use a ratio table because it's when there are two equal ratios of comparison. And when you're talking about probability, you notice that you are comparing it all the time, the event versus the total outcomes. So your probability is already a ratio, and that's why we could write it as fractions. So when you're making predictions, you can always use that ratio to make a ratio table to help. So for an example, the probability of rolling a 6 on a number cube is 1/6. So that tells me that to roll a number 6 out of the total is that there's 1/6 out of 6 numbers on a number cube. If the number cube is rolled 50 times, which is my total, how many times will it be rolled? So all we need to do is find the scale factor. Well, 6 times, 6 goes into 50, 8 times, and that gives us 2 left over. So I notice that 6 goes in 8 times with 2 out of 6 remaining. Well, if I multiply that by 1, then I know that it would be rolled 8 times, 8 and 2 6 times out of 50. Now, I don't like to leave my fractions not simplified, so I'm going to simplify it, and I get 8 and 1/3. So every time, about 50 times I roll the dice, I'm going to roll it about 8 times. A 6 will be rolled about 8 times. Every time it's 50. Because that's my prediction. Now, again, this is a prediction, which means this is what should happen, not that it actually does. So if it should happen, we are talking about theoretical in predictions. Theoretical is what should. Let's try some more. Kinsey surveyed a random group of 7th graders as to which they preferred video games, sports, or neither. We're going to use these survey results to make predictions for the entire 7th grade class with 350 students. Now, does that mean it's going to be exact? No, because this isn't experimental. This is a theoretical. It's a prediction. So when I look at my table, I know that 15 like video games, 22 like sports, and 3 are neither. What it doesn't tell me that I need to do is I need to figure out my total. So I know that there is a total of 40 students in this table. So when it says, what is the prediction for 7th graders who preferred video, I'm talking about video versus total. And in this table, 15 prefer video out of 40. But my prediction wants the whole 7th grade class of 350 students. So I need to find my scale factor. So 40 goes into 350 about, I don't know my multiplication facts. I need to write it out. 40, 80, 120, 160, 200, 240, 280, 320, about 8 times. And I get 30 left over. Bring down my decimal and my 0. And 40 goes into 307 times. And I get 20. And it goes in 5 times. So my scale factor is 8 3/4 or 8 75/100. So I need to multiply that by 15 to get my prediction. So I multiply by 15. 35, 36, 7, 43, placeholder, 5, 7, 8, 2, 13. So that means out of 350 students, about 131 in 2500s would prefer video games. Now, there's not really a decimal person. A person can't be a decimal. So when they're asking for a prediction, you could either predict 131, since 2500s is less than, or since it is still part of a person, 132 is a good approximation. Okay? I'm going to leave the second problem for you. I'm going to be looking for that in your notebook. I would like for you to try that one yourself. And that's going to be my check-in point for tomorrow. And it'll also be my check-in point when you're studying. When you're studying for probability, that would be a good problem to make sure you understand how to predict. Okay? So for another problem, I'm going to look at number 11. It says a basket of beads contain 8 red, 6 yellow, and 6 green. That means that there are 20 beads. If a bead's going to be drawn 60 times and it's replaced, which means it's an independent event, it's not going to affect it, what is my prediction for a green bead? So if I look at my original, I had 6 green and I had 20 total. But I'm going to draw it 60 times. So I know that 20 times 3 is 60. So my scale factor is 3, and 6 times 3 is 18. So I'm going to have 18 green beads drawn. That's a prediction. Is it exact? No, because it's theoretical. Let's look at another one. Number 12. A bag contains a total of 100 black and white marbles. So I have 100 total. Without looking, a marble is chosen recorded and placed back in the bag. The student records 8 black, 2 white, and we want to know how many black marbles are in the bag. So what they didn't tell me is the total, but I know if I have 8 black and 2 white, I have 10 total. And I know for sure in the bag there's 100 total. So 10 times 10 is 100. Therefore, there are 80 black marbles in the bag. Again, a ratio table helps you compare and make proportions. I'm also going to leave number 13 for you. So definitely try number 13 out, write in your notebook, and also be ready when you're studying because that's definitely going to help you understand this unit. If you have any further questions, please let me know. Send me an email, talk to me in class. You have my information. And rewatch this video as many times as you need. Have a great day, guys.